we're going to do some Algebra 2, OSA 2A21. The student will factor a sum of cubes. And this is lecture 11.2 and 11.3. I guess I'll talk about, I wrote this down so that we could know what we mean by cubes. The cubes we're going to be working with today will be the result of a monomial, that's like a number or a variable, or the product of a number and a variable. Just a monomial that's been multiplied by itself 3 times is what we call a cube. And so, for instance, here's what we can think of as cubes within the context of what we're going to do today. 2 times 2 times 2 is 8. Therefore, that's what these 3 little dots mean. Therefore, 8 is a perfect cube. 8 is a cube. The cubed root of 8 is 2, because 2 times 2 times 2 is 8. So 8 is a perfect cube, and the cubed root of 8 is 2. X times x times x is x to the 3rd power. Therefore, x to the 3rd power is a perfect cube, and the cubed root of x to the 3rd is x. 3x times 3x times 3x is 27x cubed. 3 times 3 is 9 times 3 is 27. X times x times x is x to the 3rd. So therefore, 27x to the 3rd is a perfect cube. And the cubed root of 27x to the 3rd is 3x, because 3x times 3x times 3x is 27x cubed. So these are perfect cubes. And because you can multiply something by itself 3 times, that will yield this. Okay, so forth and so on. So that's what we mean by cubes today. Some cubes we'll be running into on a regular basis are these numbers right here. These numbers are perfect cubes because you can multiply something by itself 3 times. 1 times 1 times 1 is 1. 2 times 2 times 2, that's what 2 to the 3rd power means. 2 times 2 times 2 is 8. 2 times 2 is 4 times 2 is 8. 3 times 3 times 3 is 27, so forth and so on. All of these numbers are perfect cubes. So if I ask you, what is the cubed root of 125, you would tell me that it's 5, because 5 times 5 times 5 is 125, okay? Cubed root of 64 is 4, because 4 times 4 times 4 is 64, so forth and so on. These are cubes, perfect cubes, that we're going to be running into quite a lot. So bear those in mind. Be looking for them. To factor a sum of cubes, which is our objective for today, the student will factor a sum of cubes. To factor a sum of cubes, that means we're going to have 2 cubes that are added together, and we want to break it into 2 chunks, which we call factors, such that if I multiply those together, I get a sum of 2 perfect cubes. So I want to break this into 2 factors, and this is the pattern that we use right here. If you're given a sum, that means addition of 2 perfect cubes, and you want to factor, use this pattern. And rather than go any further about why this works and whatnot, I'm just going to demonstrate how it works, and then on the very last example I'll show you that it does indeed work. If you multiply this times this, you'll get this. So here we go. Factor each of the following. In each case we're going to have a sum of cubes. So I'm going to show you how to factor it. I look at this and I say, well, this is x times x times x. This is one of those perfect cubes I told you about further up in the lecture. 125 is 5 times 5 times 5. So we can think of that as 5 cubed if we want. That's a perfect cube. To factor this, I'm going to use this pattern right here. I'm going to open up a small set of parentheses for a binomial and a larger set of parentheses for a trinomial. And I'm going to pre-place my plus and minus signs. Look at these plus and minus signs here. I'm going to pre-place mine. Plus, minus, plus. Okay, now all I've got to do is figure out what goes here, 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 and here, and I've got a factor. And here's how this works. You take the cubed root of this one, it's the thing that's being multiplied by itself 3 times, and you put it here. You take the cubed root of this one, that's the thing that's being multiplied by itself 3 times. And if we go back up here, the thing that's being multiplied by itself 3 times is 5. So the cubed root of 125 is 5. So I put the cubed root of this one here. Then we're done with this. To figure out what goes here, here, and here, we follow this pattern. Square this one. Multiply these two together. Square this one. Oops, I said square this one, I didn't square it. Square this one. 5 times 5 is 25. When I say we're going to square something, that means we're going to multiply it by itself. So quickly what I did was I said, hey, this is a sum of two perfect cubes, so I'm going to use this pattern to factor it. I opened up a binomial and a trinomial size set of parentheses. I pre-placed my plus and minus signs. I went plus, minus, plus, plus, minus, plus. And then I filled in these values, these terms, by using the pattern that I just showed you. I'll do another one right here. I look at this one. I say, hey, that's a perfect square, perfect cube. That's 2a times 2a times 2a. 2 times 2 times 2 is 8. A times a times a is 8 to the third. So 2a times 2a times 2a is 8a to the third. 1 is a perfect cube because 1 times 1 times 1 is 1. So I have a sum of two cubes. So I'm going to use that same pattern I just did here. I'm going to open up a binomial size set of parentheses and a trinomial size set of parentheses. And I'm going to pre-place my plus and minus signs. If this is positive, I'm going to put a plus sign here, the next one's a negative, and the next one's a plus sign. Now I've got 5 places I need to fill in, and I'm just going to figure out what to put there using this pattern. I take the cubed root of this one and put it here. Well, that's 2a, because 2a times 2a times 2a is 8a cubed. I take the cubed root of this one and put it here. 1 times 1 times 1 is 1. Once I get these two, I'm done with this. To find out what goes in these 3 spaces, I just square this one. 2a times 2a is 4a squared. Put it here. Multiply these two together. 2a times 1 is 2a. And then square this one. 1 times 1. And I'm done. If I multiply this binomial times this trinomial, I'll have 6 terms, but all of them will cancel out except for a cubed plus 1. By cancel out, it means they'll be exact opposites. You'll add them together and they'll turn to 0. You'll see when I work them through for you here in just a second. Okay, here's another sum of two cubes. 27, as I said, here are cubes you're going to run into a whole lot. 1, 8, 27, 64, 125, 216, 343. These are cubes that you run into all the time. I look here and I say, hey, here's 27, u to the third power. So this is 3u times 3u times 3u. Plus, this is 125, that's 5 times 5 times 5. So this is a sum of two cubes. That means it will factor using the sum of cubes pattern, which is a binomial times a trinomial, plus sign, minus sign, plus sign. Pre-place your plus and minus signs. It makes it a little bit easier. And then we take the cubed root of this one. That's the thing that's being multiplied by itself. That's 3u. 3u times 3u times 3u is 27u cubed. Take the cubed root of this one, put it here. That's pretty sloppy. Take the cubed root of this one and put it here. Take the cubed root of this one, put it here. And we're done messing with this. To figure out what goes in these blanks, we square this one, multiply it by itself. 3u times 3u is 9u squared. Multiply these two together for this one, that's 15u. 5 times 3u, 15u. And then square this one. That means multiply it by itself. 5 times 5, put that here, and we're finished. If I multiply, if I multiply this binomial times this trinomial, I'll get this. I have factored this sum of two perfect cubes. Okay? And we'll do one more and then I'll demonstrate that it actually works. I got x cubed, that's x times x times x, plus 64. That's 4 times 4 times 4 from our list above. Sum of two cubes can be factored. Binomial times a trinomial. Pre-place your plus and minus signs. Plus, minus, plus. Take the cubed root of this one, the thing that's being multiplied by itself. Put it here. Take the cubed root of this one, the thing that's being multiplied by itself. That's 4 in this case. 4 times 4 times 4 is 64. Put that here, and we're finished with this. To fill in these blanks, I square this one. X times x is x to the second power, or x squared. Multiply these two together, put it here. And then square this one. 4 times 4 is 16. So I've got it factored. That means if I multiply this times this, I'll get this. And I'm going to go ahead and demonstrate that on this one. I could pick any one of them to demonstrate it, but I'll just do this last one to show you that it does indeed work. Here we go. I'm going to take this x and multiply it by these 3, and then take this 4 and multiply it by these 3 terms. Then I'll combine like terms, and what will be left is x cubed plus 64, unless I've made a mistake. So here we go. X times x squared is x to the third. That's x times x times x. X times negative 4x is negative 4x to the second. That's negative 4 times x. X times 16 is positive 16x. So I got x times x cubed, x times x squared is x cubed. X times negative 4x is negative 4x squared. X times 16 is positive 16x. They're both positive. Now I'm going to take the 4 and do the exact same thing. I'm going to distribute that 4. So this 4 will be multiplied by these 3 terms. 4 times x squared, positive 4 times x squared is positive 4x squared. Positive 4 times negative 4x is negative 16x. Positive 4 times positive 16 is positive 64. Okay, so I have multiplied these two a binomial times a trinomial, these two quantities. I've multiplied them together, and I've gotten this. And I should have gotten this. Well, let's take a look at these. Negative 4x squared plus 4x squared. That's a fancy 0. 4x squared minus 4x squared is 0. 16x minus 16x. I'm combining like terms. Well, 16x minus 16x is another 0. And so that all I'm left with is positive x to the third plus 64, which is what I should have gotten. That's what factoring means. We've broken this into 2 chunks, which we call factors, such that if I multiply these 2 together, I get this. And that's what we're doing. We're factoring sums of cubes. This was just a demonstration. This was just a demonstration that it actually works. Okay. I hope that made sense. I know you can do this. Go get them.